So we're still in worksheet 2. This is page 7, and we left off with letter D, and this is what our graph looked like. So the question is, in the first trial, the skater was farther along at 2 seconds than he was in the second trial. Does this mean that he is going faster? If you remember, in this trial right here, we had gotten a speed of 3 meters per second. So this was the second trial. In the first trial, we got 2 meters per second. Okay, so it says the skater was farther along at 2 seconds than he was in the second trial. Does that mean he was going faster? Not necessarily, because the starting position in trial 1 is 10 meters. And so you need to look at that. The starting position in trial 1 is 10 meters. So that puts him out ahead to begin with. And then the starting position in trial 2 is only 4 meters. So he's starting back behind. Okay? So that doesn't mean just because he was farther along at 2 seconds in the second trial that he was traveling faster. So you also have to look at what is the starting position. Now, the last part in this one, letter E, is that a linear relationship gives you a straight line and an equation that can be written for this line. The equation for a linear relationship is this y equals mx plus b. Now, we calculated the slope for this line, and we did that up here. And we got 3 meters every second. That means the car or the person is moving 3 meters every second. The y-intercept of this line is the starting position, and the starting position is where does that best fit line cross the y-axis. And right here it was at the 4-meter mark. Okay, so that's where it was. So if we want to write the equation for this, so our basic equation is this. Y equals mx plus b. B is the y-intercept right here. That's what B is. So we know what that is. It's 4 meters. Plus m is the slope, and we calculated that earlier. That's what m is, the slope. So that's 3 meters per second. X is, you go up to the graph and you look, what did you graph on the x-axis? It was time. And y is, what did you graph on the y-axis? And this is position. So that's what we put in for x and y. So this is time. And then this equals the position. And the position it equals is the position final. So that would say after you're traveling 3 meters every second, and if you do it for a certain number of seconds plus 4, it should tell you where are you going to end up at. Where's your ending spot going to be? Okay, so we'll look at that a little bit later. So the next one, so this is the last set of graphs on the worksheet number 2. So we're looking at a little bit different data set. So we need to scale out. It looks like our greatest time is 12. So we need to put 12 seconds on our graph. So we're going to go 2, 4, 6, 8, 10, and 12 will be the next one. So this will be 14. And then the greatest distance we have to move, it looks like we've got to get to 12 meters. So if I scale this out, I'm going to go by 4, 8, 12. Okay, so every one is 2. I'm just not putting every number on there. So we're going to plot this. So it looks like at 0 time, we're at 0. That's right down here at the origin, we call that. At 2 seconds, I'm at the 6-meter mark. At 4 seconds, I go to 4, it's right here. I'm at the 12-meter mark. At 6 seconds, I'm again at the 12-meter mark. At 8 seconds, right there, I'm at the 8-meter mark. At 10 seconds, I'm at the 4-meter mark. And then at 12 seconds, I'm at 0. Okay? Now, I'm going to draw my trend line on here, and my trend line looks like this. Like that, then like this, and then like this. Okay? So we're doing a trend line on here, following where are the dots marked. So the question is, what do you think is happening between 4 and 6 seconds? So right here, what's happening here between 4 and 6 seconds? Because here's 4 and here's 6. Look, if I'm at 12 meters and then 2 seconds later I'm still at 12 meters, wouldn't I be at rest or stopped? So I'm going to be stopped. And the reason would be is I'm at the same position. If I stay at the same position, and that's what we're saying here is this is at 12 meters and this is at 12 meters, I must have stopped. Okay? So what do you think is happening between the interval of 6 seconds to 12 seconds? 6 seconds to 12 seconds is going to be from here to here, right? Because here's 6 and there's 12. It looks like if this is my origin right here, didn't I move back to the origin? So I moved back to the origin. And how do I know? Well, aren't I at 0 position? I'm at 0 position at 12 seconds. Okay? So I'm at 0 position at 12 seconds. That's at the end of the time here. Now, they want me to determine the skater's average velocity. Okay? Now, to do this, I'm going to take that off. When we do average velocity, we want to take the final position minus the initial position. Where am I? Right here at the beginning. At the beginning, it looks like I am right here at 0. At the end, I'm also at 0 meters, right? Because isn't this 0 right here, meters? I'm saying position. So my final position is 0 meters. 0 meters minus 0 meters divided by the time that went by. That's what elapsed means. Well, if I'm here at 0 and this is 12 seconds, isn't that over 12 seconds? It looks like 0 divided by any number is 0, right? So this is 0 meters, because this would be meters per second. Nothing cancels out. So that's my average velocity. What is my change in position over time? Now, this is one that we typically are more interested in when we talk about our daily lives, is what is your average speed, okay? So average speed is the path length traveled, I put this in here, divided by the time that elapsed. The time that elapsed is still that 12 seconds, right? Because we're saying from 0 to 12 seconds. Now, how much did I travel? Well, if I look at this, I started here at 0, and I traveled to 12 meters, right? And then I stayed at 12, and then didn't I go from 12 meters back to 0? So that's 12 meters. So if I did this, I went 12 meters here, and then I went another 12 meters, and then this would be 0 meters because I was sitting at rest, or just standing there for a little bit. So doesn't it look like I traveled 24 meters when I add this 12 to this 12? That's the path length. How far did I actually walk? And this looks like I must have been going 2 meters per second. That would be average. Now, that average doesn't tell us, though, that you stopped and rested, but that's just your average. Okay? So this takes us through worksheet 2 on how to answer these problems about these graphs on position time.